My name's Nick Beenham. I'm a distinguished engineer at Comcast. I became involved with the Radius program but towards the end of 2023. And this is a bit of a talk about how we sort of see Radius at Comcast and the potential and how we want to sort of maybe integrate this into our developer platform.
Great. I'm Jonathan Smith. I run product management for the Azure Open Source Incubations team. So we're the team that created Radius and contributed Radius and a number of other projects to the CNCF. And I'm happy to be on stage with Nick. He's our superstar community member, sort of leading the pack in terms of contributions to Radius. And we're hoping that more folks in the room here, as you learn about Radius, will follow in Nick's illustrious footsteps. I'll provide a little bit of context about Radius and the incubations team, and then really the bulk of the content today is Nick talking about how Comcast is using Radius. So the Azure incubations team has a mission to work across the open source community to deliver technologies that help accelerate our collective journey to the cloud, right? So we don't focus just on Azure customers or Microsoft customers, but we look at the industry at large. And because we're working with the industry at large to accelerate everyone's migration to cloud, our ship vehicle is open source. And since our ship vehicle is open source, we partner with the CNCF. So once we have a project that we think has value and has legs that we've been incubating, then we contribute that project to the CNCF. And they've just been great partners in terms of building community around the projects and helping drive our open governance approach. So that's been a great partnership. Most folks that I talk to at KubeCon are familiar with some of the projects that come out of Azure Incubations, in particular, CADA and Dapper. Are projects that folks tend to be familiar with. A lot of times folks don't realize that those two projects came from the same team, and oftentimes also don't realize there's a pipeline of projects coming out of this organization, including Radius, which we'll talk about today, but also Copacetic, which you see in the bottom left corner of this portfolio slide, and Drosy as well, which is a cool project that hopefully you'll join me right after this presentation. We'll be going downstairs to see a presentation from the Drosy team. So in terms of Radius specifically, the way to think about Radius at a very high level is it's a cloud-native application platform that's focused on making it easy to define an application one time and then deploy it to whatever cloud you prefer. That could be on-premise, AWS or Azure. Those are the cloud environments we support today. Others in the future. Most of the customers we work with are platform engineering teams that to utilize Radius need it to be extensible, the ability to define custom resources for their platforms, and integrated with popular technologies that they're already using in their internal developer platform. So Radius runs and deploys applications to Kubernetes, leverages Terraform, has tight integration with Dapper, is integrated with popular GitOps tools like Flux, Argo CD in the backlog, Backstage. There's a Radius plugin in the pipeline for Headlamp, so lots of integration there to make it easier to leverage as part of an internal developer platform. There's a number of questions that Radius kind of seeks to answer in the context of developer and platform engineering challenges that are listed here, namely, how can we help platform engineers working with developers to maximize productivity without developers getting too bogged down in the complexities of Kubernetes. Likewise, how can we help developers work kind of seamlessly across different resources they need in their application, whether that's a Kubernetes resource or services from different cloud providers like AWS and Azure. how can we help platform engineers enforce things like security, operations, and cost containment best practices without putting too many kind of onerous constraints on application developers. And then lastly, how can Radius provide guardrails that make it easier for developers to work with AI to build and deliver applications and infrastructure deployments that meet the high bar for enterprise-grade applications. And the way that the general approach that we take to answering those questions at kind of a high level architecturally is a system that's based on what we call a universal control plane, or the Radius UCP. And the notion there is that I, as an application developer, should be able to leverage a broad range of resources, whether that's containers running in Kubernetes, whether that's Dapper building blocks, whether it's open source APIs like PostgreSQL or any number of cloud services. I should be able to define any one of those resources in my application with a consistent syntax, ask the Radius UCP to deploy that application. The UCP then in turn works with the control planes across AWS and Kubernetes and Azure to deploy those resources so that you define your application one time, deploy it unchanged across those different clouds. That's sort of a very quick kind of drive-by introduction to Radius to provide a bit of context for what is kind of the star of the show, which is Nick.
No, thanks, Jonathan.
Yeah, man.
Awesome. So to pick it up from where Jonathan left off, Microsoft came and saw us back in sort of late 2023, I think it was, with this idea about Radius, and we were sort of quite intrigued from the outset. We were already having some challenges with Kubernetes with our developer community, and I will say developer, not platform engineer, because some of them will get upset with me. But being a developer myself, some of my colleagues who are in the audience were getting quite fed up with me slacking them, asking me to fix my deployments for me. So when Radius came along, it gave us the opportunity to say, okay, you can define it in a manifest that brings together both your application and your infrastructure in a format that is relatively easy to understand compared to the complexity of Kubernetes. I was all ears. The other thing that we kind of wanted to sort of start looking at is how can we, I want to say that the ecosystems are starting to sprawl quite a lot. And you can see it here with the number of projects and the number of different applications that you can all mesh together to build a platform. The cognitive loads does start to get quite large. And when you're managing all these little manifest files, and with multiple points of access and update to these platforms, the risk of drift is fairly significant. And then the last piece, which I just sort of mentioned at the outset on this slide, bringing the concept of the application and bringing the application into the same sort of space as the infrastructure and being able to deploy all of that as one cohesive unit was also quite attractive. But there is a but. So what we needed from Radius is we wanted to simplify that Kubernetes complexity. But what Radius came with originally was things like Microsoft SQL Server, which we don't run a lot of. So one of our sort of early questions is, well, this doesn't really work for us. And to their credit, and this is the first time it's ever happened to me in my 20 years, they said, well, how can we make it work? Most people will say, well, it's too bad, so sad, off you go. But not the Radius team. So we were very grateful for that. And some of my colleagues and I, we started working down this concept of, well, for us to make it work for us, we need to be able to define what we run ourselves. And this led over a couple of months of back and forth and lots of meetings and issues and pull requests to this idea of custom resources, where you can define in a very simple format your resource, whether that be a database, it could be an AI connection, anything you want, observability, you name it, it's possible. So with the thought of Radius as a control plane and bringing together these custom resources, we started to sort of like really kind of see the value here and the value proposition here of how can we build this into a platform, not just for one cluster, but how can we manage like multiple clusters, geo-distributed clusters from a single control plane? And this was, quite promising and quite impressive. And the orchestration and how we could manage the life cycle within our sort of development life cycle to, again, deploy that as a cohesive unit. So all the versions match up into one manifest and one SBOM to become a lot more consistent. Makes rollbacks easier too. All right, where are we? Oh, come on, click. All right, so Radius resource types. This is what the custom resources ended up being. So again, as a team, we came together, we brought these ideas with us some requirements around keeping it simple, emphasis on things like consistency, having it defined once and then implemented across different platforms via recipes, and leveraging things like reuse and the simplification of just being able to author your application in a very consistent way. So this is kind of how it looks like, So we're going to take a PostgreSQL database here as our sort of first example. And when you see the environment 1, 2, and 3, I'm going to put my glasses on so I can read this better, where the first environment is Kubernetes. So the recipes are created per environment, but the underlying type doesn't change. So as your platform engineering teams implement these recipes, they can scale them out from Kubernetes to, say, AWS, to Azure, and in the future, GCP. And it's the same thing that's getting deployed out. So it's a write once, run anywhere kind of model. And one of the premises that with Radius that we also did like is that we could bring everything that we already had. You have the ability to bring in your Helm and your Terraform. Terraform's used as an example here, and be able to run it natively. So a lot of times when you adopt a new technology, it's a case of start over. I have to rewrite everything that I have. And Radius didn't require that of us. So it allowed us to bring in the Helm. We have a ton of Terraform. I mean, we've been like happy Terraform writers for a long time. We even have somebody that wrote a book on it. So, and then as we're sort of designing here, we have a recipe for our test environment, a recipe for production. It's the same module with different parameters passed in. Okay, and then this is just sort of reaffirming what I was just talking about leveraging our existing modules, reducing that environment drift because everybody's using the same modules in the same way, using the same recipes. The recipes are then sort of separated from the application developer. The application developer builds their application manifest. Recipes are developed by the platform engineering teams, and then the types are authored as well. So we have a little demo here. This is where. Okay, so what you see up on screen just now is literally what a type is, a custom resource type. And this is it. So there's a name, a description. We have no excuses for not writing good descriptions now with AI. I know it was never a great thing in the past. But one of the things we want to be able to do is bring this together into resource, an example of what this resource looks like to the developer, and then the name and the other description. Let me just move this on a little bit. And then a bunch of parameters. Properties are entirely up to you. You can have as many or as few as you want. They are either optional or they're required. And then there's a little section down the bottom, which we'll scroll down to in a second. There we go, where we list our required properties. And that's it. I mean, it's simple enough that even I can understand it as a developer, right? This is not difficult. And this is some of the beauty of it and the amount of engineering in the background that went into it. So when we presented this to the developers and to the engineers, that it was something that was very simple and very easy to adopt. So moving on to the recipe, this is for Kubernetes. So it's very similar to, and if you're familiar with Radius at all, you'll recognize a lot of this bicep anyway. And you'll also start to recognize some of the pieces that look a lot like Kubernetes. So as we sort of come down, we see the service, because here we're defining a Neo4j database. We see the service, we need to get access, so we define that. Looks very Kubernetes-like, so it's familiar to most people. And as we keep scrolling down the file, we come up against the stateful set. We start defining the volumes and the mounts and the claim templates, along with the containers, ports, etc. And you can add anything else in here as well. You want custom properties, anything that's in the container spec for the image. And then lastly, when we get down to the output, this is kind of like the important bit for the recipe, this is what gets then presented to the application. So the output gets output. This is these are the parameters that are then available to your application. So kind of like normal ones you would expect, like host, port, username, password, and environment, which ties it all together. And then I'm going to let it click on. And then this is, as promised, how simple it is. There's 6 lines of code there to create your Neo4j database. That's it, 6 lines. I've spent quite many few years spinning up Neo4j databases, and it's never been this simple for me. So I appreciate it. Thank you, Jonathan. And then just in how we create them, again, there's only 3 commands. So we do a rad resource type create. It contacts the control plane, packages up those recipes and type files, and registers it. And we're done. That's it. And that's now ready to be used. Well, not quite. There's another command just coming. This didn't take so long when I was doing it, when I was practicing it. There we go. So we do a publish extension. So this is going to basically package it up into a zip. And then you could publish either to any bicep-supported registry, so GHCR or Azure registries are supported for this, or you can just keep it as a tarball on your local machine, as long as you tell Radius, the CLI, where to find it, which we'll see in a second, in our bicep.config.json. There we are at the bottom there, where it says Radius resources.tgz, and that's it. This is all ready to use now. I think that should be the end of this. Yes. All right, so the results that we saw. Now, I don't know about this one because I did look up the dev stats as well for me, and it says I have 248 contributions.
Yeah, that's what we show on our side. And this data you said was just showing 50?
This is, so when they showed the cloud contributor cards at the keynote yesterday morning, I was like, oh, I'm going to do mine. And then I shared it quickly amongst my peers to see, But then I was kind of questioning that number. But anyway, that's immaterial. But some of the things that we saw about, and not just the Radius piece, but actually engaging within the open source community, which is something I'm quite ashamed to say I hadn't done enough of, in my 20 years in this trade. We did a lot more. Not only did it sort of open our eyes to different ways of doing things. At Comcast, we have a habit of building things ourselves to what we think is right, but engaging with the wider community does sort of open your perspective up to new things and new ways of doing things. We did a lot more than just the custom resources. We did secrets. Secrets was quite painful, I remember, at the start. You had to mount them using PodSpec, so we fixed that. And then it made you feel good, and I met a lot of really nice people along the way. So there was lots of benefits to this. And we have a successful application deployment. I have an application running, at Comcast that I use at the moment, which is sort of turning, let's say, into an internal developer platform. It's growing. And what we're doing is we're using Radius as a way to sort of scout out all the things that we don't know with a relatively low-risk platform. So there's nothing that I'm doing with Radius that's going to interrupt you watching the Super Bowl. So don't worry about that. And then part of it was like, why build an entire thing yourself when, I'm Scottish, so I'm quite cheap. if I can leverage Microsoft to help me build things, then I'm absolutely going to do it. But it also, it was good. It was good to get out there and work with some people I hadn't worked with from before. I made a lot of new contacts, and some might even call them friends. And yeah, it's been fun. And then, join the community and build awesome things. All right. So I've only got a couple of slides left, so you'll be glad. So one of the things we started thinking about was and I said building it into our developer platform is, what does that workflow look like? So how do we introduce the developer, which is mostly me at the moment, to picking the right Radius components, developing anything that's not already existing, and then blending it in together, integrating it in. So one of the things we did was we don't really run GitOps as such. We do a lot of actions, but more in the way of pipelining. So as it commits, we pull it in, and we have written a GitHub action that will sort of trigger and then deploy using Radius onto our infrastructure, building out what it needs. And this is all managed by the universal control plane on Radius. Things that we're starting to look at now are things like, how do we sort of extend some of these types to include observability? So that comes in as well, and different policies, things like RBAC and whatnot. And we have quite a rigorous sort of access policy for using AI. So how can we start thinking about governing some of that as well? And then just in our sort of closing to say lessons learned, start small with defaults. The first thing that we pushed out was a very small application with no users, just no risk. So codify the standards as types. As you start finding the things that get done more than once, turn them into a type and take them with you. The user experience one was something that we didn't really think much about at the start, but definitely sort of start to grow towards the end, working with our developers to say, what's useful to you, what works, what doesn't, what's confusing, and trying to sort of iron out as many of those wrinkles as possible. And then just reuse our existing tools. Comcast has been around for a long time, so we have a lot of stuff. And as some of my colleagues will tell you, we've bounced from one technology to another, and the average lifespan is about 2 years. So the migration cost is quite high. So not having some of that migration cost is very attractive. And then I think I'm going to let Jonathan close.
Great. Thanks, man. So Nick talked some about the 250 odd contributions he's made. That's everything from bug fixes to some pretty significant work in kind of a core Radius code. And then he showed his contributions around the Neo4j resource type. And that's all kind of in that count of contributions. The part that's not quantified was a lot of the feedback that Nick and the Comcast team gave around sort of feature prioritization and key gaps to address in Radius, which has been super valuable. They've been, close kind of partnership in terms of design reviews for key features in Radius. So it's been a really valuable partnership that we've appreciated a lot. And part of why we're here is kind of to encourage more folks in the room, ideally, to join us and at whatever level of engagement and contribution that suits you. It would be great to have you as part of the community. Getting started and joining the Radius community is really pretty straightforward. We've done a bunch of work on docs recently to make those a lot cleaner and a lot easier and faster just to get up and running with a quick start, to get through tutorials and learn quickly about the kind of concepts that make up the foundation of Radius. If you want to dive into code and making contributions in docs or otherwise, as I mentioned earlier, Radius, along with the rest of the Azure Incubations portfolio, is freely available on GitHub under Apache 2.0. Dig into GitHub and get involved as you see fit there, suggesting features, fixing bugs, adding features like one and all are welcome. And lastly, Discord is our support channel. If you're interested just in sort of lurking there and seeing the kind of dialogue that happens, the team's super responsive and loves to have new folks join and get involved with that conversation. So we'd love to have you involved there. There's a lot more that we have at KubeCon. We've had the last couple of days Radius demos, Radius kiosk in the product pavilion. We've got the Drosy team will be presenting right after this presentation downstairs in level 3. Love to have you join us there. We'll have the Drosy team in the kiosk number 1A in the project pavilion in the morning, and the whole team will be there, right? So you talk about Drosy, but if you have questions about Radius, like let's dig into that, because we'll all be there to cover the Radius topic as well. One of the demos that we'd love to share, we didn't have time to cover here, is a natural language interface via an MCP server in the context of Radius, so that you can start with just a straight up code base for an application and just ask Radius to help you create your container images, define a Radius application definition file, deploy that application to whatever environment you choose. So super compelling kind of demo of how Radius provides guardrails for those kind of paired programming scenarios between AI and developers. So hopefully you'll have some time and inclination to continue the conversation we started here today. And thanks again, Nick, for giving me the opportunity to be on stage with you today. You've been a great partner, and look forward to the next phase here.
Sounds good to me.
Great. Thanks, man.
All right, thanks, everyone.
Thanks, everybody. So I think we're out of time. Well, we got 1 minute. You said autographs or questions?
I don't know, I'll take either.
Either one, autographs or questions. So come one, come all. Yeah, go for it.
Thanks for the great talk. Just had a quick question about the Terraform integration. So like we're using Crossplane Terraform workspace, so then you kind of lift and shift your Terraform into a Crossplane resource, and then it can execute on the cluster. Is it similar where you can kind of embed it in the resource definition, and then it runs in the Radius controller in the control plane?
Yeah, sorry. Yes, I'm not familiar with that. I'm familiar with Crossplane. Like I wasn't kidding when I said I was a developer. But as far as I know, it's similar. You can just bring it up and integrate it directly.
Nice. Thank you.
Oh, here comes Sergey.
One thing caught my eye is reusability. So how to reuse resources, resource types created by others. Is there a marketplace where lazy people can go and get inspired?
Yes, there is.
Asking for a friend.
If you go up to github.com and Radius project, you'll see there's a resource types contributing repository there, which is like, for one of a better phrase, a marketplace. People can contribute their types and use other people's.
And that's an area where there's a lot of opportunity with not a ton of work to contribute resource types to Radius. That adds a lot of value, both in terms of resource types that you might need internally, just like Comcast and Nick needed the Neo4j resource. Any resource that you need that would make Radius more valuable and usable in your enterprise, we'd love to see those contributions. It's a pretty seamless extension point for Radius, adds a ton of value in cases like Neo4j in the context of Comcast. But since they contributed that to GitHub, it's there for the benefit of the rest of the community. So we'd love to see more of those and input on the experience of contributing resource types like that. Great.
All right. Thank you, everyone.
Thanks, everybody. Thanks, Nick.